So suppose Chihuahuas have a mean weight of 4.945 pounds, so mu is 4.95, and a standard deviation of 8.825. So that's our sigma. Now we're going to look at samples. We're going to do the sample distributions of size 8. And we want to find the mean and standard deviation of the sample means. So it's not the mean and standard deviation of Chihuahuas in general, it's the mean and standard deviation of the averages. So we just have formulas. We're in mean land, so x bar land. So mu of x bar is just equal to the mean, which is 4.95. And then sigma of x bar is just the original one, and then we divide by square root n, because sample size changes it. So we do 0.825 over square root 8. And we get 0.29168. I like 5 digits. All right, and so what's the expected error? So again, this is all from the definitions in the chapter. Expected error was 2 standard deviations, so we're just going to double that number that we just found. So it's 2 times 0.29168, which is 0.58336. So that means we should be within plus or minus 0.58336 of the mean. So we should be a little above or below that 4.95, 0.58 above or below. So would it be unusual if we were off by 0.5? No, because that's smaller than the expected error. So error of 0.5 is smaller than the expected error. All right, and so let's say we've decided 0.58 is too much error. How do we decrease the error? We just increase sample size. Sample size is the best way to change the amount of error. So let's see what happens when we change the sample size to size 25. So A, the mean does not change. The mean is still 4.95. But since sigma uses sample size, sigma will now be 0.825 divided by square root 25 instead. So the standard deviation changes because the error changes. So we're going to get a different number this time, 0.825 divided by square root 25, which is 5. And we get an error, a standard deviation, of 0.165, and doubling that would be our expected error of 0.33. So expected error is always within that 2 standard deviations, and that has to do with that 2 cutoff point that we've been talking about over and over. So 0.33. So now we should be within plus or minus 0.33 of the mean. So we should be a little bit closer. So now, would being off by 0.5 be unusual? Yes. An error of 0.5 would be unusual because it's more than the 0.33. And so all of these formulas were in 7.3 and 7.4 because we're looking at means, right? 7.1 and 7.2 were proportions, 7.3 and 7.4 were means.